Okay, so this is what you had in your very first, very top of the page, okay? This is something that you talked about in Algebra 2 for sure. Between the table and the graph, what's happening? How do we describe? Okay, the X's and the Y's, they are switching. Okay, that is something that I was wanting you to remember. So X's and Y's, they switch. Okay. Okay. What I want to point out for this graph right here, and mine got really blurry. I know yours is a lot more clear than mine is. But when we have a graph, you're always going to have this reflection about the line y equals x. Do you recall talking about that in Algebra 2? Okay. Whatever our graph is, the line y equals x is what we are going to reflect it about, and then that is our inverse graph. Okay. Now, when we talk about our x's and y's switching, I want you to make a note to yourself that that also means domain and range. Okay? We're talking about the concept that our x's and y's switch places, then that also occurs with our domain, the x's, and our range, the y's. So whatever your domain is for your original function, that's going to become the range for your inverse. Vice versa, whatever your range is for the original function, that becomes your domain for the inverse. Okay? So that is something that we're going to talk about as we go through today. When I ask you to find an inverse, I'm also going to ask you to find its domain and range. Okay? Now, the vertical line test. Who can verbalize that to me? What is a vertical line test? Just use words, describe what it is.
It's how you tell if the graph is a function.
Okay, and so what do we do with our vertical line?
See if it hits the graph or line, whatever it is, twice.
Okay, so if it hits more than once, not a function, right? Okay, we have something that's called the horizontal line test. So if you want to put this on the back of your green sheet, if you want to put this in your notes, but I want you to be aware of what the horizontal line test is. Okay? It's the same concept as the vertical line test, where we're seeing if this line passes through more than once. But what it's going to do, it's testing to determine if an inverse exists. Okay? Not all functions are going to have an inverse. If a function does not pass the horizontal line test, it's not going to have an inverse. So I want you to just think real quick about a graph that would not pass the horizontal line test. Think about it. Maybe whisper it to your neighbor. Okay. Emma Ralston, what kind of graph would not pass? Okay, a quadratic would not pass the horizontal line test. A parabola is not going to have an inverse. Okay. Now, if I had half of a parabola, would that pass the horizontal line test? Okay. And that would have an inverse, but not a full parabola. That's going to become important here in a little bit. Okay? So then, you're not going to see this very much, but a function that is one-to-one means it's passing the horizontal and vertical line test. Okay? If we're one-to-one, every 1x has a 1y. All right? We're passing both of those. So if a function is one-to-one, okay, if an equation is one-to-one, then it's a function and it has an inverse. Okay. All right, let's get back to our green sheet. Okay, So the very first thing I asked you to find was the inverse of this right here. Okay? So Addie, describe to me what you did to find the inverse.
I first wrote it like with the y,
Mm-hmm.
and then I switched the x and y's, and then I solved for y.
Okay, I like that you described that to me. Thank you. So f of x is the same as y, so she changed it to a y, and then our entire definition of what is an inverse, we switch x and y, and then you said you solved for y, and when you got y, what did you have?
I had f to the negative of x equals x plus 9 over 3.
X plus 9 all over 3. Okay. If you wrote that as 1/3 x plus 3, that would also be the same thing. Okay. I also appreciate that you wrote it in that function notation. Okay. So we switch x and y, we solve for y, and then since I'm asking you for an inverse, I'm going to ask for it in function notation. So if you'll just recall that f to the negative 1, that means f inverse. Okay. Now, both ways I would accept these answers. So if yours is one versus the other, okay, that is fine. But what I told you we would consider is the domain and range. So let's go to this original function right here. Okay. What kind of function do we have? We have what? We have a line, right? Every time, what's the domain of a linear function? All real numbers. Okay? If I have a linear function, slope of 3, what's going to be the range? All real numbers. So this one is not that exciting, is it? Because domain's all real numbers, range is all real numbers. We don't really get to see this switch happening, but we know that the domain and range are also going to switch. So the domain and range of our inverse is still all real numbers, all real numbers. Okay, not that exciting, but we have at least talked about it. Okay? Where it gets a little bit more exciting is the next one that you did. So number 3, you solved f of x equals radical x minus 3, the quantity plus 7, right? Okay, so let's just, before we talk about what you did with your inverse, let's just talk about what the domain and range is for this function. So what I want you to do is I want you to take a moment, think about what that graph looks like. Remember, we have a square root and it's been shifted. As a pod, I want you to come up with what the domain and range is for that function. Graph it if you need to, or at least graph it mentally, but come up with the domain and range. I'll give you a minute or so.
I'm not even sure if the right
To the square. Yes, because since we're dealing with all of these like function transformations, it's a lot easier for us to think about that graph with just the square.
So basically, the shifts
So we have a square root function that has been shifted right 3 and up 7, correct? Okay, there it is. So if I asked you for the domain of this function, Nate, what would you tell me?
I said bracket 3 comma infinity.
Okay, good. We have that shift to the right 3, so now our domain starts at 3 and gets bigger. Guy, what's our range?
Sorry.
You can do it. It's Monday morning, but you can do it.
I don't know.
Where did our y? Here, I graphed it up here for you. This shooting star shifted up 7, right?
Yeah,
So where do our y values begin?
7.
Okay, and they go until. Where do they go until? Okay. That's okay. You're just excited. I appreciate the excitement. Okay. So now I do have some questions that I need to address as far as finding the inverse. Okay. Remember, f of x is the same as y. As I walked around, I noticed that we all did a good job of switching x and y. Okay. Please be careful of your order of operations. So we want to solve for y and what y is underneath the radical. So we need that alone first. So we need x minus 7 equals radical y minus 3. Then what would you do with both sides?
Square.
Okay, now here. The square root and square cancel. Let's just leave x minus 7 squared as x minus 7 squared. Okay, please don't worry. Now, if you did, it's fine. But don't worry about, please don't worry about, thank you, multiplying that all out. And the reason is we've been working with function transformations. So we've been working with quadratics that look like this. Would you agree? Okay, so let's leave it that way. All right. So for your answer, I want that the inverse of x is x minus 7, the quantity squared, plus 3. Okay? On your test on Wednesday, I'm going to ask you to identify this domain and range. I mean, not this exact one, but, you know, of an inverse. So if it were this exact one, how many of you would be tempted to tell me that the domain is all real numbers? You don't have to raise your hand, but, like, why would we be tempted to say that domain is all real numbers? Because it's a quadratic. But what did we talk about? Do quadratics have an inverse? No. Only half of quadratics have an inverse. And let's think about what we're working with here. We're working with the square root function. Okay? When we reflect over the line y equals x, that square root is only half of the parabola. Okay, so we identified the domain and range up here for our original square root function. What do we have to do with those? Switch them for our inverse. So this is something that you'll need to add to your green sheet. The domain of this is 7 to infinity, and the range of our inverse is 3 to infinity. Just be very careful that you think about what you're taking the inverse of. If it's a square root, you're only getting half of a parabola. So that needs to be reflected in your domain and range. All right, let's talk about that challenge problem. How was that? How about this? I'll tell you the answer. And so you could either have like a victory or a pity party.
I've already wrong.
That's the answer. Okay, that's the answer. Now we're going to go through how to get it. Okay. Let's first, though, identify the domain. Can we do that? Identify the domain? Okay. Brayden, help me with the domain. What do we need to be careful with of this function right here?
You can't have the denominator zero.
And what number would make that happen? Okay, so for the domain of our original, you told me -1. We have to exclude -1 because that is what would make the denominator 0. Okay, now we haven't really talked about how to find the range of a function like this. In chapter 2 we will. So if you have a rational function that I'm asking you to find the inverse of, let's just think about the domain of the original, and then when we get to the end, we can talk about how to go from there. Okay? So everyone should at least have this step. X equals y over y plus 1. Right? We switch x and y. We should at least have that down on the challenge problem. Okay? What makes us uncomfortable? There's 2 y's. Anything else? Fraction. Okay, so let's take care of the fraction part. If we don't want a fraction anymore, what could we do? Multiply that denominator over. So let's take this guy and multiply it over so we have x times that denominator equals. Okay, so some of us had at least that step, and then this is really where we were like, oh my gosh, I don't know what to do. There's 2 y's. What do I do? Okay, that's fine. There's 2 y's. Okay, so let's maybe find a way to get both y's together. So let's first distribute xy plus x equals y. And since we have 2 different terms involving a y, let's get them together on one side and anything without a y on the other side. So what I'm going to do, I'm going to have xy, I'm going to subtract this y over, and then I'm going to subtract this non-y term to the other side. So now my y's are on one side and my non-y's are on one side. Okay, look at that left side. Look at that left side. What's in common with those 2 terms? A y. And what can we do if we have 2 terms that have something in common? We can't combine them because this guy doesn't have an x. But instead, we can factor out a y. Okay, now Monique, now what can happen? I have y times x minus 1. If I want y all by itself, what can I do with x minus 1? We can divide it over.
Is there something else?
Yep. Okay, so our inverse, let's just change that to f of inverse. Okay. Those of you who got to here, okay, good job. Only a couple more steps to go after that. And we are going to practice another one, so don't you panic. All right. Before we do that, let's talk about this. We can easily identify the domain of this rational function because we have a denominator, right? Okay, we have a denominator. Kaylin, what do we need to exclude from our domain?
Whatever makes it 0.
Okay, and in this case, what is it?
1.
All right, so our domain, everything except 1. Think about it, don't answer it. How do we identify the range of this function? Jessica, what do we need to do? It's the domain of the original. So we already thought about the domain up here. It becomes the range of our inverse. yes, this is something I would expect you to know how to do for Wednesday's test. I'm not asking you a linear function for an inverse. You did that in algebra 2. Okay? So, should we maybe practice another one so we can kind of get the hang of these steps right here? Here we go. Yeah, that's perfectly fine. You do what you gotta do. Okay? So I am going to give you a few minutes, maybe like 3-ish. We'll see where we are in 3-ish minutes. You and your pod work together on going through the steps to get to the inverse. We'll talk about domain and range later. If you have time, talk about those, but at least get the algebra down. All right? So here you have a y term and here you have a y term. So since you moved this 3 over, let's maybe move this x-y term over here with the y so that, well, it's being added, so I would subtract it. Okay, so now, let's go back to over here. So you see how, so since we had 2 terms of the y factored, so over here I would factor it out. Yeah. You didn't switch it from like. I did. But this should be like. Oh. Yeah, all your X's. No, it's good. I didn't see. So many important stuff. Okay, so do you see right here that our y is together? Okay, so like since you have a y over here, over here, I would subtract that so that your two terms with a y are together.
Yeah, we made it to the last like 5 minutes.
So
before you factor them out. It was like I thought you factored it out. So that would be all on your line.
Yeah, you say that the adjustment there might be, like this 3 doesn't have a Y.
No.
It should not go through.
It was someone saying dominant.
Or at least have it come. Okay, so that's what you're
Yes, I know what you're saying.
Y times Y is X. Y times Y is X. Y times what gets Y. Y times Y.
Wait, X.
Y times Y is
Okay, so we're gonna walk through this. We're gonna walk through this. Okay. So we have x equals y minus 3 over y plus 2. Everyone did a nice job of multiplying that y plus 2 over. And make sure you get that distributed through. Okay. Now this one was a little different because we're working with 4 terms. The other example had only 3 terms. We're still working with the same concept. Y, anything with a y on one side, anything without a y on the other side. So some of you kept this xy term and subtracted this y over, which means you would have to subtract this 2x over with the minus 3. How many of you did it the other way? Okay, so some of you kept the 2x and added the 3, which means you had y on the other side and subtracted your xy, right? Okay, so I'm going to go through it both ways and show you how we're still getting to the same thing. Okay, so our next step, we have 2 terms that involve a y, so factor out that y. Okay. And then y is being multiplied, so you would want to divide that factor over. Okay, while these 2 answers look slightly different, they are the exact same thing. Okay, let's talk about y. Here our denominator is x minus 1. Here our denominator is 1 minus x. So do you see how these denominators are opposite? Which means our numerators must also be opposite. Okay? If I factored out a negative 1 from this right here, we would have exactly what we have on this right side. Okay? So both answers work. Yes?
I got negative x plus 1 for the denominator. And I don't
Over here?
Yeah.
Okay, let's look at your work right here. When you factor, or up here, do you have y minus xy?
I put negative xy plus y.
That's fine.
Okay.
So then when you factor out the y, you should have negative x plus 1.
Oh, I put minus 1. Oops.
Okay. Okay. Great. Now, let's talk about the domain of our inverse. Okay? The domain of our inverse. Which number, Austin, do we need to exclude?
1.
We need to exclude 1 because we do not want to divide by zeros. Now, when we look at the range for this guy, think about it. When we look at the range, what do we need to consider? For the range, what do we need to consider? Emily, what do you think?
I found the domain of the original one.
Okay, and what number do we need to exclude of the original? Okay, so the domain of our original is everything except -2, because we don't want to divide by 0. So the range of our inverse, we will exclude -2. Tony, thank you for being excited. Questions about that? Okay. Okay, what I'd like you to do is I want you to find the inverse with the domain and range of this function as I hand back your quizzes. I'm going to hand them back upside down, and you will not look at them until after we've discussed this problem. Okay? I'm just trying to save some time. A marshmallow in front of a 2-year-old? Okay.
Look at Jessie. She's the one that ate it.
No, 4.
4.
Oh, you just switch it.
Jessie said I missed. I'm just too to watch this one. Wow.
Yeah. I know, I would scrub to everything, and I feel like that's I just like shared with you, that's automatically better. So I just scrub to everything. It makes sense. Domain I got bracket 0, comma, and then range I got bracket 2.
I knew that already. I don't know what you're telling me.
All right, so let's talk about this one. X equals square root of y plus 2. We switch x and y. Our first step would be to square both sides. We don't have anything added or subtracted. We don't have to worry about it. So automatically we can square both sides. X squared equals y plus 2. So y is x squared minus 2. Okay? When you determine the domain and range of this inverse function, what's the easiest way to go about doing that? What should you think about? Okay, let's look at the original. So our original is a square root shifted left 2. Okay, all right. Function aerobics. So Kaya, what's our domain for the original?
We said it was -2, the bracket.
Okay, so our domain for the original is -2 to infinity because we have that shooting star shifted to the left 2, right? And then, Kinley, what would be our original range? Okay, 0 to infinity. Great. So now, our domain and range for the inverse, we switch it, change it. What do you think? Can we handle that? I think that your greatest challenge on the assignment will probably be the algebraic side of the work. In particular, you're really going to have to pay attention and focus during the rational ones, okay? I've already told you, you're probably going to see one like this on the test. So I would not suggest skipping over those or avoiding those on your homework. If there's one that is not bolded and it's a rational one, I would maybe think about doing that one, even if it's not required. Okay? Let me go ahead.